Okay, so the next question that we have is you want to find the equation of the set of points P. You want to find this the equation of. You want to find the equation of set of points P. Set of points P, the sum of whose distances, from basically from these 2 points, A, which is 4, 0, 0, 4, 0, 0, and B is negative 4, 0, 0, is equal to 10. Is equal to 10. Okay, so if I assume that, for example, the point P is some point in space whose coordinates are x, y, z, for example, then the distance between P and A would be AP, and the distance between A and B is equal to BP. The distance between P and B would be BP, is equal to 10. So now basically AP would be the square root of x minus 4 whole squared plus y squared plus z squared, and because over here you have basically y minus 0 whole squared, z minus 0 whole squared, and then you have BP, which is the same thing as basically x plus 4 whole squared plus y squared plus y squared plus z squared is equal to 10. Now what you can do in order to simplify this equation, what you can do is that you can basically, if you leave this as it is and then, for example, raise both sides of this equation to the second power, what you will get is that, so this would be, for example, a plus b whole squared, which is equal to a squared plus b squared plus 2 times ab. So then you would get basically all of these terms out of the square root function, and then over here you would get out of these terms out of the square root function. But then over here 2 times ab, you would have 2 times this whole expression times this expression, meaning that still your terms would be trapped under the square root function. So in order to avoid that, what you want to do is that you can write this equation as x minus 4 whole squared plus y squared plus z squared, and you can write this as 10 minus, and take this to the other side of the equation. So that would be x plus 4 whole squared plus y squared plus z squared. And then now you can basically raise both sides of the equation to the second power. If you do so, you will get basically, well, I just simply do it this way. Raised to the second power, raised to the second power. What you will get is basically x minus 4 raised to the power 2 plus y squared plus z squared is equal to, and this is a minus b whole squared. So a minus b whole squared is equal to a squared plus b squared minus 2 times ab, which is a squared is equal to 100 plus b squared is equal to this whole thing whole squared, which is x plus 4 whole squared plus y squared plus z squared plus z squared, and negative 2 times AB. So negative 2, that would be 2 times 10 is equal to 20. So that's negative 20 times the square root of x plus 4 whole squared plus y squared plus z squared. And so now what you can do is that you can simplify this a little bit, meaning that you can write x squared plus 16 negative 8x plus y squared plus z squared is equal to 100 plus x squared plus 16 plus 8x plus y squared plus z squared minus 20 times the square root of x plus 4 whole squared plus y squared plus z squared. And then you can simplify x squared with x squared, y squared with y squared, z squared with z squared, and 16 with 16. So then what you have over here is basically negative 8x, and then you have 100 over here, positive 8x goes to the other side, becomes negative 8x. And then you have 100 over here, you have 100 over here, so you can write negative 100. Negative 100 is equal to negative 20 times the square root of x plus 4 whole squared plus y squared plus z squared, which is basically equal to negative 16x minus 100 is equal to negative 20 times the square root of x plus 4 whole squared plus y squared plus z squared. And then you can write this as multiply by negative 1, you will get 16x plus 100 is equal to 20 times the square root of x plus 4 whole squared plus y squared plus z squared. And then you can now raise both sides of this equation to the second power, meaning that you can write this as this whole squared plus this is equal to this whole squared. Now 16 squared is equal to 256. 16 times 16 is equal to 256. So that is 256x squared, and 100 squared is equal to 10,000. And then you have 2 times 16x times 100, which is equal to basically 32. 32 times 100 is equal to 3200 times x. So that's plus 3200x. And the other side of the equation is 20 squared is equal to 400 times x plus 4 whole squared plus y squared plus z squared plus z squared. And then you can, what you can do over here is basically divide by well, you know, 32 is basically 2 times 16, and in order to know how you can simplify this, So that is you do need to take well 256. I know that 256 is 2 raised to the power 8. So 2 raised to the power 8 is equal to 256. So 256 is equal to 2 raised to the power 8. Now 10,000, you can write it as 2 times 5,000, as 2 times, well, 2,500, 2 times 1,250, 2 times basically 625, and so that's 2 raised to the power 4. So I'm going to divide each of these terms to 2 raised to the power 4, and then see where that takes us. So 2 raised to the power 4, I write over here 2 raised to the power 4 times, and so 10,000 is the same thing as 2 raised to the power 4 times 625. So then what I can do is that 2 raised to the power 8, so I get 2 raised to the power 4, which is equal to 16x squared. So this is basically 16 is the same thing as 2 raised to the power 4. So 2 raised to the power 4 times 2 raised to the power 4 is equal to 2 raised to the power 8, which is 256. Now 10,000 divided by 2 raised to the power 4 is 625. And 3,200 divided by 2 raised to the power 4 is 3,200 divided by 2, you will get 1,600 divided by 2, you'll get 800 divided by 2, you'll get 400 divided by 2, you'll get 200. So that's 2 raised to the power 4 times 200. So 200x is equal to basically 400 times x plus 4 whole squared plus y squared plus z squared, and then what you can do now, 2 raised to the power 4 and 400, let's divide these two first. So 400, you have 2 times 200, you have 2 times 100, you have 2 times 50, and 2 times 25. So that's 2 raised to the power 4 times 25. So this is 1 and this is 25. And then basically you have 16 times x squared plus 200x plus 625 is equal to 25. Well, I don't really have to write this really. So what I can do now is that I can write 16x squared plus 625 plus 200x is equal to 25 times, but this is x squared plus 16 plus 8x plus y squared plus z squared. So 16x squared plus 625 plus 200x is equal to 25x squared, and 25 times 16 is equal to 33, 12, 15, 25, 004, 400. So that is 25 times 16 is equal to 400. 25 times 8 is equal to 44, 16, 20, 200 plus 200x plus 25y squared plus 25z squared, and 200x and 200x you can cancel out, and then over here you will get 16x squared minus 25x squared, so these two are taken care of, negative 25 y squared, negative 25 z squared, and then over here you have 625 minus 400 is equal to 0. 16x squared minus 25x squared is equal to negative 9x squared, negative 25y squared, negative 25z squared, and 625 minus 400 is equal to 225. 225 is equal to 0. And your equation is then 9x squared plus 25. Okay, so if I multiply by negative 1 here, I get 9x squared plus 25y squared plus 25z squared minus 225 is equal to 0. And that is the actual correct form of the equation. I had to do this, I did this once, and somewhere I did make a mistake and my answer was, well, wrong. Now I go over here and I want to plot these 2 points in GeoGebra and see what we get as the answer. It's a good idea to know what your answer actually means in terms of a graph. Okay, so your points are 4, 0, 0. That's 1 point. You have another point, negative 4, 0, 0. That's another point. And then you have a line over here, which is 9x squared, 9x squared plus 25y squared plus 25z squared minus 225 z squared minus 225 is equal to 0. And as you can see, which is of course a very beautiful graph over here, and as you can see, so what GeoGebra has done, it has taken one of my points as A, it has assigned B to the other point that I have over here, and it has called this EQ1, meaning that then inside GeoGebra, whatever you want to do on this equation, probably differentiation and integration and that kind of thing, you can just write, for example, the integral of, for example, EQ1 or something like that. So that is basically the I cannot really see much here. Okay, so these are the negative y's, these are the positive y's, these are the positive x's, these are the negative x's, and of course this is your z, and as you can see, the points are along the x-axis positive 4 and negative 4, and this 3D geometric figure is like a sphere, basically. It's actually like a sphere. Okay. Now we had some three-dimensional ellipse. Is an ellipse, not a sphere but an ellipse. It is actually an ellipse, and of course, by the definition of the question, of course, the definition of the question was actually the definition of an ellipse, because it said that find the equation of the set of points P, x, y, z, the distance of the sum of whose distance from these 2 points are equal. And I think ellipse is, of course, an ellipse is a conic section basically in a 2D system. But whatever this thing is called, I really don't know. I'm not really sure. But that's what it is. That is what it is. Very beautiful. Okay, so basically we are done with these exercises here. The next part that we have is we will talk a little bit about the section formula. We have some exercises here and some exercises here and some examples, and that's the last part in this section or in this chapter. I'll see you in the next video.